Okay, should be streaming now. Let's see. Yeah. Cool. Now I just need to get the link here. Stream settings. Cool. Okay. I guess I just want to make sure that this is going to be cool. All right. So here we go. Just close my door here. What we have here is some generated faces, or NIMs, I should say. And I have a pretty good system now of basically consuming entropy from a byte stream and turning that into any kind of data structure. I've currently done this a bit with the colors. They're mostly black because I want to start generating the colors sort of afresh. And just to show you what that looks like, a lot of this is sort of boilerplate in some sense, but the important part comes here. So coloring transform generators. This is a list of items. You can see there's 3 items here, and each one informs, given a source of randomness, it's a binary source, it's just ones and zeros, and given a template, how do we modify the template? And then you also return the any remaining source. So this one just returns the same source because it doesn't actually consume any entropy. We started everything out with black. This one, however, does return a remaining source that comes from consuming color from palette. That's where that first, so you can see we take the color result and put it on the forehead. That's why the foreheads are randomly colored. And the next step, just to demonstrate the sort of iterative generation we can do, is that we take the source and the template, and again, we're returning the same source because we don't inject randomness, but what we do is we add some color here. Yeah, I think actually I can make this a bit more concise. Add vector to color. I think we can just do that. Should work and do the same thing. Yeah. Anyway, and so you can see that, whoops. You can see that all we do is we take the forehead color and we add the vector to the color. So we're adding some blue, red, green, blue. We're adding 0.3 blue. These are not 0 to 255, they are 0 to 1. So we're adding a chunk of blue there, and that's why if you look at these eyes, they're generally bluer than the forehead. So you can see this forehead ended up being black. It's a dark blue there. This gray ended up being a light blue. Yeah, we can make it a bit more obvious if we want. Just change it to a 6 and come and refresh. 1, refresh. There we go. So now the eyes are generally quite blue, but still related to the forehead color. Yeah. So what I want to do now is start injecting more randomness in here. I'm currently just doing this for the coloring, but by copying a bit of this boilerplate again, I can do the same for the structure. The structure, in a way, is the more exciting one. I think I just started with the coloring because it was a bit more unknown to me. Yeah, you can see the consume structure is just giving a test structure, whereas the consume, if I go to the consume color, consume coloring, this is a lot more intense. I suppose what I could do is go and copy this to the consume structure and just get some structure randomness in there. That might be worth doing. Yeah, let's do that. So I'm going to copy this here. This is a binary source, gives a result of list gen error. This should have the same, yeah, basically the same signature here. Now, here we're going to have to change this to indexed structure transform generator, which we'll have to define full source list.length coloring transform generators structure transform generators. And then here we'll do blank, oops, structure. So a lot of this is actually, this might not be the most interesting way to start the stream, but I would like to start modifying the structure a bit, because that will be fun. Indexed structure transform generator. Let's go find the indexed color. Copy this. And then we do structure template here, which has yet to be defined itself. This we can also maybe go up here and define it here. So you can see this template structure is just a way of sort of collecting either the result or the error that we get when we try to generate this stuff. I make this by basically going to types and getting. So this is the structure we want to end up with. But we want to make all of these, I want to resultize these. So we're going to go result gen error like this. Okay, we have that defined. We don't have this defined yet either. We'll define that next. And we might as well put that next to the coloring. And just like, so this is a list of, these are both list of ways, let's see, methods to take the binary source and make a transformer for the coloring template. A transformer just takes one, gives you another one, and then it also spits out the remaining binary source. So we're going to do the same thing here, very similar anyway. The difference being, of course, this is not going to be a coloring template. It's going to be a structure template. Let's just do this. Actually, let's do empty list for now. again, so just like how this is a list of sort of instructions for how to mutate in the coloring, this will be a list of instructions for how to mutate the structure. But before defining that, let's go hunt down the rest of these errors. Right there. Full source. That's just an easy switch. That. And then the blank structure template. We need to define that, which we can probably do up here. Yeah, let's actually put it here. Move this guy up as well. And so what we can do is we can just, let's make it easy to count. Use a multi-cursor to count this. Copy that, paste it here, go like that, and then delete in space. Now we have, and then what we want to do is select this word and go error not yet set. I should have done almost everything. We just have one more here. Error not yet set. Now that should work. So what we've done is we have a structure template, and then the blank structure template just initializes all these as the gen error of a not yet set. If we look at the gen error type here, there's a few, and not yet set is one of those possibilities. That's a union type. So we're just starting this out with, oops. Oh, that's, oh, right, I need to go. There we go. Okay, still getting some errors though. Structure template finalizer. That's what takes that template and turns it into its structure. So we have the structure template, but then in types we have the structure, which there's no ambiguity here. This is everything is set. And for the coloring, we made, where's that finalizer? There it is. So this is definitely some not very interesting boilerplate. And it takes a lot of copy kung fu here, multi-cursor kung fu. But we can at least get the signature down. So as we generate this, we get a possible list of errors, and we get a structure template which also can contain errors. And we want to be able to take that tuple and turn it into sort of just a strict result, where the error mode is just a list of gen errors, and the OK mode is structure. So in other words, this function, like this one, will either return a coloring thing, which we know has everything set unambiguously, or we'll get a result of errors, or sorry, a list of errors. This might be super confusing for anyone who's not familiar with Elm. I promise this will get more interesting for those of you. So, errors, structure template. And we need to do this big monster case thing here and include all of the variables included in the structure here. So I'm going to take all these, copy them like that, go back. And Elm only lets you do tuples of 3. So there's one tuple. Oops. Let's do another tuple. This is definitely the boring part. I should have started streaming after this. And how many do we have left? Oof, a lot. Let's start separating this out to read a bit easier. Man, a lot of variables in here. So that would work if we could build a tuple of 5, but we need to break this down even, or we need to group this even more manually. So let's see here. I'll put these first 3 into a tuple. I guess I'll put the next 3 into a tuple. Oh, and then of, let's just put something dumb here to see. No, still getting some sort of error. Oh, we did do equals. Okay, there we go. So we got it to format, so roughly work right. We have 2 big tuples. Each item of these 2 tuples is a smaller tuple. The point is now we can test all these at once. And so we're going to do a similar thing as here. We still have that monster thing in our clipboard. But actually, let's copy this. And we're going to carefully select each one of these. I'm holding Alt to do the multi-cursor stuff in VS Code. It's quite nice. And say OK. And we'll put an arrow here. And OK, that seemed to work. You can see those are grayed out because we're not using them. We want to now use them. We're going to do the same thing here. So what we're doing here is we're basically building a list of all of these. So what we're saying is, OK, actually, here, let's start this one first. Go back to this. Take all of these again. Put it here. Put this into a structure type shape, or a record, I should say. And we can do a cool multi-cursor thing here. Copy this equals this and format. There we go. Something's not right though. Oh yeah, we need to do OK there in front of it. Okay. So we're still not done with this yet, but what we've said is, okay, take the structure template, which is full of ambiguous results, which might have errors or they might have an actual point to them. We're saying if you look at that whole, look at everything in it, and if they're all okay, then make the whole thing okay and just take the that value and put it in there, which is how we transform the structure template into a structure. And now for some reason it should be showing me an error because I need to now deal with the possibility that they're not all okay, but it looks like it wants me to deal with some other errors first. It's weird to stream and program in Elm. I feel like part of my brain is focused on the stream and I can't really focus on the code. The argument is structure template. Yeah. But It's piping it to a function that expects things about cheeks. Okay, so even though I'm consuming structure, it's talking about colors. So, aha, that's because of this, I bet. That says nothing about color. Ah, that's probably what's messing us up. Let's see if that fixes that. Okay, cool. Now we're back here. Okay. So now we're going to say, I could say this and then deal with stuff like that. Put my code in there. However, by doing it this way and explicitly mentioning everything, oh, well, I can't really copy that. It's going to be different. It's going to be something more like this. And then I'm going to take out all the OKs. Actually, let's do a multi-cursor kung fu here. So when we put OK here, we're sort of constraining the this case of we're casing out the OK version, which is not the not the error version. But what we want to do here is we want to catch everything. So I'm going to Control Enter to get rid of those OK. I'm going to rename these result like that. And so in here, by taking out the OK, we're basically making this second one a catch-all for all the other possibilities, because if this one doesn't catch, then we'll get here, and now we're back to dealing with all these as results. But at least we know that we don't have this perfect. We can't build this perfect structure. And then we'll just do something similar to here, where we're going to explicitly make an error. And we're going to, then the error type here, as well in both of these, is a list of gen error. And we're going to make that list by basically putting all of these in. Oh, I should have copied that while I have my multi-cursor down. Let me see if I can back up and get it. Yeah, let's just copy that and then redo. And paste. Okay. Put some commas. And make this a list. And put this pipe here. Now, yeah, then we want to partition this list. Result extra partition, what that does is it takes everything in here and it makes one list out of the OK values and one list out of the errors. And what we want is the error list. So we'll do tuple.second, because this one will return a tuple of one list and the other. List A, list E. List E is the errors. We want the second one. We want the errors. Okay, and then that is not being happy somehow. Where's the error? Ah. Okay, now this error. Oh. Yes. Can't mix pipes of different directions. Okay, so that seems to work. So now what we have, some boring boilerplate, is we have a structure template finalizer. It takes a list of errors and a structure template, and it gives you a single result, which is either a structure or it's a list of gen errors. So that's nice. Okay, everything else is building now. So let's see. If we've done this right, we should be able to transform the structure. We have no transforms right now. And I believe that it will start with the blank structure template, which is a bunch of errors. So if I just go and rip, this should have empty, we shouldn't see anything. And if we look, we'll see console. Yeah, not yet set. So that's what we would expect. And we can maybe fix that by doing the same thing I did on the color and transform generators. Is the first one we're going to do is just going to set everything to black. So, for example, we set the iQuad to OK color black, which moves it from the error moves it from this error. So we've done that with coloring. Now we just need to do that with structure, and then we should see basically, well, it's not going to be that easy because, well, here we can do black as a default, but what is the if we look at the structure type, these are points. So I guess we'll just use the test structure here. This is the structure that I've been showing off. This is what creates the little fox-looking guy. So probably the problem is I can't easily turn this test structure of a structure type into a, into a structure template. But I could just copy this raw text, and let's just, source. So given a binary source here, remember there's a list of functions that turn a binary source into this stuff over here. So given a source, create as a function that takes a template. And I'm really just looking down here and copying the spirit of this. And then when in Elm, when you have some name in curly brackets followed by this bar sign, you're taking a record and you're updating some number of variables in it. So now we can probably paste, and then we'll have to do this, and do that, and then let's go one more up, and then we just need to make this an OK value. Now that should work. Okay, it does. Now it does not. I think we just need to import that. It's funny in Elm, so if I just Control Z a little bit and save, you see the error over here is a certain size, and when I add something in and save, the error gets bigger. That's actually a good sign in Elm, because it means that your code is making enough sense for it to highlight larger structures and say there's something wrong with this bigger piece. And here, I think what it's going to say is you're returning a function, the transformer, but you're not returning the binary source. Of course, it's going to tell us that in a very weird way. But I'm pretty sure that's what's happening, and so we just make this a tuple where the first one is the function there, and the second one is the remaining source, which in this case is just source because we didn't actually use any randomness. Save and end that. Okay, there we go. So now, because the first transformation basically ignores the source and it gives an OK value to everything, we should be back to displaying something. And there we go. Okay, so now we have the structure that we're seeing. The points of the ears and the eyes and the nose and everything is actually coming from this stuff right here. And so we can start changing this. So let's just, for one example, let's make this crown. So we got X, Y, Z. Let's make the Y one just to show you guys what that looks like. So that should make the crown much higher. And indeed, the crown has gotten higher. That's that, yeah. A lot of these points are defined on one half of the face. So this crown point, if I go back and refresh, you can see just right there, that point is the point we're talking about, and then it's copied over to the other side. So just by changing this one point, I change both sides, and that's how we get that symmetrical face, even though we only define half the face usually. Well, yeah, half the face in terms of points. Now, we can start adding some randomness here. Let's just make a, okay, here's an easy random thing just to demonstrate the power of all this framework that I've put up. Let's do another transformation here. Source, template, and remaining source. So I don't have that value yet. And so we're going to be using randomness. So we're going to use, let's see, similar structure as here. In fact, we might as well just copy this and modify it. Let's do that. So we're not doing color result. We're doing, see, this consumes color from palette. We don't want to consume the color. We want to consume point. I'm just thinking it might take a little bit more work to get that to work because I don't have that function yet. I have consume int, but that's about it. I haven't really done much else. And then I have a consume color from palette, but I don't really have a consume point yet, which is what I want. But maybe just for quick demonstration purposes, I can consume an int. So if I do consume int with, I can do by bits or by max. So if I have a max value that I want, or just a number of bits I want to consume, let's do bits. So if I do, let's say 3 bits, that should give me something between 0 and 7. And consume it binary source. Now that will give me a maybe. I'm treating it like a result though, because I'm testing for errors and okays. That's fine. We'll just do just. And we'll treat the nothing separately here in a moment. And this is not going to be a color now. This returns a maybe int binary source. So just, wait, is that right? Yeah, int, of course. Let's say, let's call this, so we're getting an int. What I want to do is make the ears longer or shorter, just as a really basic thing. So let's say y change int, and then s. And this is going to be totally different. And we're not making a color result, we're making, let's make it a ear point y. So if the consume int with bits worked, it won't work if the binary source is too short, by the way. If I wanted like a 50-bit int, but there were only 30 bits left in the binary source, it would not work. That's why we have to do the maybe. So if we're in the just here, that means that we had enough entropy to consume, and if there's nothing, if we get the nothing back, that means we actually ran out of entropy. We'll deal with that in a second, pass that error up. But for now, so we have a y change int and the ear point y. So let's look at what that ear point is. Where's that ear? Ear tip. So 0.3D meters, x, y, and z. The y is what we want to change. So the 0.8 is what's giving us that. Let's make the range from 0.4, which will be much shorter, to like 1.5, which would be quite large. Let's just write those down. So 0.4 to 1.5, and we want to take this y change int and put it into that range. So let's say change ratio equal change int divided by 8. Let's just make this +1. Well, no, let's leave it. Let's just go back. I think I need to do a to float here to get that to work. And then we can say in change ratio times, okay, so there's about a 1 in there. So let's say 1.0 plus 0.4. We kind of don't need that 1.0 actually, but let's keep it in there for explicitness. So this is the range of the random value that we're going to get, 1 meter, and then plus 0.4 is the floor version. So we should get something between 0.4 and 1.5. Let's see if that works. No, getting some sort of error. Where is that error? Oh. Okay. So the first part of that seems to work, and now, right, it's complaining we don't know what error is, which is true. Down here we had the error because consume color actually returned an error. This one just returns a nothing, this consume int. So, but we know what that nothing means. It means there was not enough entropy, and we can actually just put that error in, which is called not enough source. Enough source. So there, and then let's make this ear point y result, in fact, and then put that ear point, is that what it's called? Ear tip equals, there we go. Does not match previous branches. Oh yeah, we need to make this a tuple too. So the first one is the ear point y result, the second one is the remaining source, which in this case is S. Still didn't work. Oh, because this needs to be an OK. Okay, bigger error. That's good. Second element does not match all previous elements. It's an anonymous function. Oh, it needs a binary source. Oh, no, wait. Yes, here's what it is. Okay, given a source, let the result. I think the problem is, which I'm not sure what the problem is. Oh. Oh, no, it's, let's see. These errors are not always the easiest to understand. Okay, binary source A, binary source A. These are both structures. There's an unpleasant error. I'm not really sure what's going on here. Doing basically the same thing here. We say the result and the remaining sources consume color from palette source. We check on it. If it worked, we say, okay, color S. That's the remaining source. And if there's an error, give the error and you just give the original source. We're doing the same thing here. Case to consume with bits is just with the y change int. Oh, I see the problem. I'm giving a float here, but this needs to, yes. I'm trying to make the ear tip, which should be a vector, a float. It's a single dimensional thing. So I need to do result.map because this is a result. I'm going to map up a function onto this. In fact, let's write it like this. So given that y, we need to do .3d.meters, I believe, and then we go ear tip dot. Let's just actually hard code this in based on what we had up here. So ear tip. We're changing the y, so 0.4 and 0.2. 0.4, y is 0.2. There we go. Okay. So now we're setting the ear tip to be a result of a point rather than just a result of a single y value. Yeah, let's see. Hey, look at that. We got different eared guys. Now that's pleasant to see. Okay, that's worth a commit. Cool, so now we got the structure and the coloring being built with some pseudo-randomness and iteratively as well. Let's see. That's a big deal. Okay, but I do want to clean this up now. I don't really, this was kind of a pain to do, to take a y and put it in to the vector. What I really want is I want a consume vector, probably specifying a certain number of bits, or bits per dimension anyway. There's a few different ways I could do this. If we go back to binary source, so we're consuming an int with bits with max. So let's just write out what else we could do. So we can consume .3dm. We could do like 9 bits like this. That could be something we call the .3dm is just a it's just a .3d with meters. It's kind of a weirdness of the Elm geometry library, not really important. And then 9 bits would represent, okay, we want to take 9 bits, 3 bits per dimension. So that's one style that we could do. We could also say, oops, consume .dm, and we could do, we could take as an argument bits per dimension, or bits per, what are they, component. That's better. Or, I mean, if I think about what we're actually trying to do here, I don't want to generate a whole, well, I kind of do want to generate a whole vector. Right now I'm just changing the y, but why not, if we look at these guys, why not make it, some of these ears more forward than others, or more to the left or right than others. So I do actually want to generate a random vector, and then I suppose I'd be scaling it in different ways. Yeah. What would maybe be best is if I do a unit, if I can generate a unit vector. So if I do consume .3d unit, that would then give me a range of -1 to 1. Well, it'd be a vector. It'd be a length 1 point in a random direction, essentially. And I could use that to define, start with some central point, and then I could say, go in a certain direction. I could actually scale the dimensions of that vector to limit, the distance it can go in any given direction. Still the question of how many bits. But I think we could make that this and an argument. Let's try making that. Let's see by using that. So, and we take and then we take the source. We just make the type signature while I'm at it. Binary source. Maybe int. Oh, that's not what we want. We want .3m binary source. I want to return the actual result, and then what's left over. So, we have this consume chunk bits, but it gives a maybe. We'd like to consume 3 chunks of bits per component, bits each. I think we can just do that in a case statement and just say it 3 times. So case, but we're each consumption will have to take another piece, so we actually have to do this pretty manually. So actually, this isn't going to make a unit vector. I mean, I could make it that way, but I guess I will make it that way. So let's make a note here. Whatever that means, whatever that's going to look like, just so I don't forget. Right, so x equals, we also need to consume float, actually. Let's start building that too. Consume float with bits. Binary source, maybe binary source. Bits. We can actually build this from consume int with bits and divide it by the maximum value. So we could say we're going to pipe the source to consume int with bits. Then we're going to take that, and now that's going to return this funky thing, the maybe of a tuple. So maybe that map, and then we're going to map the first of that tuple. Tuple.map first. So now we're basically, if consume int with bits returns this funky thing, maybe map and tuple map first basically lets us modify this if it's in there. If it's not in there, it just doesn't do anything, like if this is a nothing. But if it is in there, we can do something with that int. And let's give it a function. Int result, maybe a better name would be divisor int. And then we can say to float divisor int divided by, that double slash is a float division, divided by, and then we want to get the max value. So that would be, do we have a POW? Yeah. Wait, they're both from, isn't there a basics? What is it? Nope. Basics. On base. Mod by. Hey. Oh, it might be an operator. There we go. Exponentiation. Okay. To up bits. So that should be the max. So if we have 3 bits, 2 up to 3 is 8, and the divisor int is going to be between 0 and 7, I think. Consume int with bits. Chunk to int 32. That could be, yeah, that'll be 0 to 7. Consume float with bits. But we want this float. We want the float to be between 0 and 1. Let's actually make that clearer here. unit float with bits. But as it is, it won't ever get to the full one. So what we want to do is actually do this -1, because that's going to be the max value. Let's save. Yeah. So that should sort of work. Back to consume. Okay, let's actually just see if this works first. Got an error. Int. Type. The body is maybe int. Why is it maybe int? The second map should have taken care of that. What does it say if I do this? Body is maybe int. It should be returning a float though. Oh, maybe I have these backwards. Okay, I do. The double slash is for int. Okay, that makes sense. And then this needs to be to float. Okay, now let's just make sure that works. Oof. Let's see, 3 bits. Gotta give it a binary source. I hope I can just put this in. Actually, there should be a from. Unsafe from bit string. Wait, something has gone wrong there. Oh, I need to expose it. Okay, let's try that again. Okay, that looks like that was positive. Let's just stretch this out so it makes a little bit more sense here. So 111 should be the full value. This should give us 0, and this should give us an error. Very good. Well, nothing anyway. That's wonderful. And then if we do, let's say 001, that should give us a small number. Give us a bigger number. Hell yeah. And if we do 110, that should be almost 1. Very nice. Oh, that's cool. That was truly a joy. Okay, so we have that working now. Now let's work on this. Consume unit point 3dm. Let's just take out this with bits because it doesn't seem to be the way we're naming these. Oh, and then we have to go. Okay. So thing is, this is returning a maybe. We need to deal with that somehow. Yeah, see, this is awkward. How do I could do a maybe dot with default, but that will basically silence any errors we get. And if I do a case here, where I do like case, and then I could do like this, and then this, and then this. However, problem is it's using, I'd have to put the source in there too. The problem is it would use the same source, and we don't want that. We want it to be consuming the source as it goes, which is too bad, because if we had this, and we could get past that problem, then we could, we could test them each, test them all in the same case here. We can't do that. We have to consume source one by one, and we have to pass in the mutated source to each next one. Just make sure the stream is still going. It is. I mean, we can do it really ugly. I guess I'll just start with that, and maybe something better will occur to me. X and source 1. And then do that. I guess I could do some maybe dot maps, and let's see, that's y, and source 2 equals the function onto so x. And this is really should be an end then. Then I believe anyway. Consume unit float source 2. Actually, I should be doing some nested cases. That's what I'll be doing. Okay, let's start this over. This is a bit ugly, but it's not too bad. And we can pass this along like that. Whenever you do a nothing to nothing, it seems like you should be able to do a maybe dot map, but let me just not worry about that now. Source 2. Oops. Okay, then we have a point 3D dot meters x, y, z as the first. Oops. And source 3 is the remaining source, and I think we can actually just take out all this shit, although we will need to unitize it. 3M. I don't have that. Put it here. Must be in there. Yep. Okay. Point 3D dot. Do I not have point 3D at all in here? I sure don't. Okay, and then the last one, unitize, right. I can do that up here though, actually, and then let's see, point 3D dot unit to unit, no, scale. Okay, let's look up some stuff here. want to get a unit vector. Magnitude, length, width length. Okay, it doesn't seem to be. It's only the vectors and not points, which is fucking annoying. But this looks like what we want. And a direction. Oh, no, that's a constructor. That's not what we want. Scale. Multiply times vector 3D dot times. Multiply a vector by a scalar. Let's see what else is here. Have some device dot minus properties. Length. So we can divide by the length. Looks like vector 3D dot length. Let's just make this actually. Might as well. Is going to take a point 3DM because that's all we. Might as well make it generic. So, okay, we want the length. We're also going to have to turn it into a vector. Wait, no. Oops. Vector. Fuck. How the fuck do I? Yeah, from points. No, that's from one vector to another, although we can use that with the origin. Okay, let's first of all put both of these in. Put this in utils. Does a vector 3D need coordinates? It does. Hello. Cute kid. Okay. So we'll put this here. Okay. Vector 3D dot from origin point. Okay, and then we go so we got the vector there. length. Now we just need to divide the thing by the length, which, what was that called again? Arithmetic cross sum math times, or divide, no, divide a vector by a scalar. So we want to divide it by the length. Okay. This is a vector. Over. Okay, use a divisor first, so that's length. And that should just be the vector. What the fuck? No, Jesus. What up? Sorry.
Sorry, I just want to say I'm sorry I'm going to miss this evening.
Oh, yeah.
But we'll at least see you after.
Okay.
For last bucket.
Yeah, sweet. Okay.
All
See you
right,
later.
enjoy, eh?
Yeah, it's gonna be fun.
I did say to kind of mean, I feel like I can miss it because I've got a direct line.
That's right. That's right. Okay, I'm gonna have to go soon. I don't know if anyone's watching this, but yeah, unfortunately, we didn't get to do much. That was really fun. What did we do? We got ears to be displaying differently, and I'm just trying to generalize that to general point stuff, so we can use it more easily in the future, which is going to require unitizing. And this over signature, man, that kind of, I guess here's a V. Force vector 3 did over mass. Jesus fucking Christ. You know what? Let's actually just fucking skip that. I mean, we can do this. Make it a unitless. Oh wait, we gotta generate a unitless one. Now we can just say this, point unitless, and we can just literally take this yes, x component vector divided by length. Does that work? Right. What other things can we do about x? Yeah, you're seeing. What is it? In meters, so that should take a length and turn it to a float. Okay. So if we do that divided by length. Okay. accept. Okay, hi guys, I gotta head to my next thing. I'm gonna go ahead and stop streaming here. Thanks for joining, if anyone did. Might have just been talking to an empty room for all I know. I'll check the analytics later.